Welcome to BKW Physics. I'm Mr. McConley. We're going to start off our lesson a little up close here today. I got a bowling ball, and I'm going to hold said bowling ball over a student's head. And hopefully I don't get too tired, because it really is a 16-pound bowling ball. I'm getting a little weak here. But there's a certain amount of fear that said student has. What do you say?
It's rising.
It's rising, you know, especially as my arms start to quiver a little bit. Now, what is that all about? How does it relate to, have you ever gone for a hike and you hike right up to the edge of a cliff? Or you stand on your roof, or you stand on something really high and you walk over to the edge, and all of a sudden you get that like, ooh feeling, like, I don't know, I might fall over the edge. Although you know you're a coordinated person, you're not going to fall over the edge. But what is it about that, or about this, that makes you feel a little uncomfortable? Well, what I propose is that basically what's going on here, leave that there, what basically is going on is that you have learned over time a little bit of a fear of potential energy. Potential energy, you know what it can do. You know that the bowling ball held over your head, if a mistake were to happen, that potential energy is going to turn into what type of energy? Kinetic in a hurry. And based on the mass of that ball, is going to do pretty good damage, or it's going to do work on your head. Okay? You got a little bit of fear of that. Same way when you go up to the edge of a cliff and you feel like you might pitch over, it's because you know the consequence of what happens when that potential energy in your body turns into kinetic, uncontrollable, gaining kinetic energy. This is a conservation of energy, and we're going to dive into it this way. If you were to take a ball, a rock, something, throw it up in the air, let it go way up there, and let it come back down to the same height at which it started, there would be a clear conversion of energy. And we're going to just kind of step ourselves through this real quick. Now, you can't think of the ball as stopped right here. What I'm saying is, let's draw a person now. Add to the picture a little bit. This person is throwing the ball up. So right now you can see that it left their very long arm in my sad picture. And so right there, the ball has left their arm. This ball is moving with a velocity, and we'll just say the velocity is fast right now. So what type of energy does it have based on the fact that it has velocity?
Kinetic.
It's got kinetic. And leave a little bit of space because we're going to stick a number in there. Then, based on potential energy, I know it's not on the ground, but see, if this is the starting point, and then I'm ending at the same height starting point, we'll call that zero height. Even though it's not really zero height, because it could fall a little bit further the height of the guy. But what can we say about the potential energy? Well, we can say the potential energy at this point is really zero, because it's at that baseline starting height. Now, as it goes up, let's reach the top point here, the pinnacle of the ball. At the pinnacle, how fast is it moving? Now, don't be fooled, because I have drawn my picture, so you're thinking, well, it's kind of moving that way. Don't get the two things confused. This was an up and down motion. So up here, how much up and down motion do you have?
Zero.
Zero. So we can say right at the peak, we can say that the kinetic energy is zero right there at the peak. Does it have a height? Most definitely. It's way up there. I don't know how high you threw it, but it looks pretty high. It has potential energy. I'll come back with a number in a moment. Follow it through back to right here to the baseline height that you started at. Does it have kinetic energy? Is it moving? And yes, it's got kinetic energy. I'm not talking about when it hits the ground, I'm talking about right there. Yes. Does it have potential? Well, based on that this is the starting height, you can say that potential energy is zero. Now let's just go back and make up a made-up number. Let's say the kinetic energy is 100 joules that leaves your hand. What's the potential energy up here? 100 joules. And the kinetic down here is 100 joules. Simple concept. But there's one more little piece to this that some people don't realize, is that if we go halfway, we measure measured up halfway, it's the halfway height here. Here's my halfway height. What would the kinetic and the potential be at this point?
Equal.
50 and 50.
50. 50 joules of each. It'll be the same on the other side. It'll be 50 joules of each. Does this make sense, everybody? One last thing, touch on, tied into the other day's lesson. Since this number, no matter where I look, if I look at the total here, the total energy, what does it add up to? 100. If I look at the total here, it adds up to? In here, in here, in here, in here, in here. No matter where I pick, the total will add up to 100. And what is that total called in terms of our choices? If you remember, we had like potential, elastic potential, and kinetic. What's this one called? This one was the one called mechanical energy. Mechanical energy, in this case, is going to remain constant. Mechanical energy is the sum of potential and kinetic energies. It will remain the same number throughout this whole situation. In fact, there's another way to draw it. If you're not so keen on this picture, you can look at it this way. Think of it kind of like a sine wave. Yeah, two sine waves. If you think of the blue one as a potential energy sine wave, and you think of the black one as a kinetic energy sine wave, and you were to sum these vertically at any point, you would always end up getting the same number. You know what I'm saying? It would always add up to the same total. Because as one goes up, the other goes down. They're fluctuating back and forth. So what would like this point represent on this picture over here?
Midway.
The halfway point, right? The halfway up or the halfway down point. So this is just another way to see it. For some people, that visualization works better for them. So for today,